Hey, greetings and welcome, friends. Today we're starting our brand new chapter called Statistics and Data Analysis. And you might be surprised, there's a lot more to statistics than just plain old mean, median, and mode. So we're going to analyze data. And I mean, the statistics and probability tend to kind of relate to one another. But you'll see as we go through this chapter that statistics is a little bit more hard fact sort of thing. You can relate it to probability in the sense through experimental probability, I guess, versus theoretical. For instance, like actually flipping a coin 1,000 times and documenting the results versus the theoretical probability of what the likelihood of certain outcomes would be when you flip a coin 1,000 times and document the results. So today we're specifically going to build up towards frequency distribution, but we're going to talk about actually a variety of ways of representing data. Data is, by the way, plural for multiple points of data, values, numbers, sorts of things like that. And the first representation of data that I want to talk about is called a line plot. Which is, I don't know, it's a little bit kindergarten-esque, but that's fine. So a line plot uses symbols to show frequency of a particular category or outcome. All right, so that's a line plot. So a visual of what a line plot might look like. Here's my line plot of apples, oranges, bananas, pineapples, kiwis, and coconuts, where the frequency is represented by a symbol. Yeah, I got kind of lazy with my sketches over time, right? So here it turns out we have 5 people who liked apples, so the frequency was symbolized by 5 apples, so that got more and more lazy as time went on. There were 5 people who liked oranges. It looks like there was only 4 who liked the bananas and 4 who liked pineapple, and looks like 5 who liked kiwi. And coconut is 4. Good stuff. So a line plot uses symbols to show frequency. You might have seen a line plot when you saw that SpongeBob episode when he went to driver's school with Patrick and he got the good noodle stars. And the number of good noodle stars that he got was kind of like a symbol representing, right, the frequency of the number of good things he did in class, right? So that's a line plot, and it measures the frequency of information. So the next type of information display that we'll consider is a bar graph. Bar graph. And actually, to do this, I might actually even pull up height of bars. Let's see, here we go. Let's see if I can fit this in here. This is going to be so awesome. There we go. Yeah. Look at that. It's like it grew there. Bam. You can't even tell. It's only like a little sloppy. So we've got a bar graph, and in order to do this, I'm actually going to make a nice little table in Excel because with data, computers are actually really good at representing data. We're actually going to do some work with Excel or Google Sheets, and I'll show you some of the different possibilities within these computer software packages here, so to speak. So let's make a bar graph together. So it shows the frequency of data using the heights of bars to measure frequency. So instead of measuring with a symbol, I'm now using a height of a bar. So here's my little Excel, and let's say I've got this. I'm going to call this let's just write apples, oranges, bananas.
I like to eat apples and bananas.
I think maybe
Kiwis. So let's just get a quick poll, gather some data here. How many people like apples? You can vote more than once, by the way. Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8. It looks like all 8 students here in the room today like apples. How about oranges? Same show of hands. 1, 2, 3, 4, 5, 6, 7. Oh wow. Okay, so one less. All right. How about bananas? Everyone likes to eat apples and bananas. That's great. Pineapples. Oh yeah. Wow. I've got some real confident like hand raises here. The coolest thing about pineapples, by the way, you guys can put your hands down for a second. Pineapples, I buy like canned pineapple tidbits. It's like 89 cents. And it's the only canned fruit you can buy that has no sugar added. It's not like in a syrup mixture. It's in its own juice, and it's so good. Oh, I love it.
We watched a video today. It's really freaky. It's about those things that you buy.
It's not a real
you
thing.
have sugar.
Mr. Project saw
Okay.
ad on it on email, watched the whole entire thing, and thought it was a real thing.
So anyways, how about kiwis? Show of hands, kiwis. Wow, man, you guys are all fans of fruit. And how about coconuts? Boo. Boo, coconuts. You heard me. I said boo. So what I'm going to do is insert a chart. And you can see a bunch of different options here. Actually, up at the top here, ladies and gentlemen, please, please, please. I know we're excited about our fruits today, but yeah, you can represent things differently. Area, bar chart, and actually the bar charts for Excel, they seem to be like horizontal bar graphs. But what I'm describing is more what Excel calls a column graph, right? Is what they seem to be referring to here. Question, comment, yeah?
Are we going to have to use this Excel for our homework?
I'm going to equip you guys with some stuff that will make things easier as a Google spreadsheet, so that way you can just do it right from like your email or whatever and on the internet without having to own Excel.
Even more work.
Then it's more work for those of us doing it by hand, sadly. But not any less doable. It's just because it's warped. I don't know. But anyways, so you can see here's an example of a bar graph where I've got the height of the bar represents the frequency, Jacob, for how many people liked those different fruits. Good stuff, good stuff.
Wait,
You
who
should have done something
was
more
the
controversial.
one person who doesn't like pineapple?
Whoa, we don't need to call them out. We don't need to call them
No,
out.
I need to know.
No, I've never had pineapple, so I don't know if I like it.
I heard of someone who's allergic to pineapple recently. So
Who is it?
it's terrible. Terribly sad. Okay, guys, the next idea is a back-to-back bar graph. Ladies, gentlemen. A back-to-back bar graph shows two sets of data, but measuring the same information. Excel doesn't have a cool way to do it, but I threw together like a fake phony one. It's really just like I just put two tables and set them back to back, and I made it look sad. But it would be like something like this, where I'm measuring the frequency of, say, 6 different things. Maybe the 1 through 6 is how many, I don't know, classes do you take in college per semester? And so maybe there are 3 females that take 1 class, and then like 3 females that take 6 classes. There is only 1 male who takes 6 classes or something like that. So it's the same exact information, but it's just displaying it broken up, aggregated into 2 separate categories. So that could be relating whatever. So that's the idea of a back-to-back bar graph. I don't know. I don't think those are all that interesting necessarily, but your book just wants you to know that it's a thing. 3-dimensional bar graph. We'll go back to gathering some more data for this. Let's see. Let's see. Over to Excel. All right, so here we go. I'm going to delete this. And in order to make a 3-dimensional bar graph, so this was, let's break this up a little bit. So, let's see, I don't know if I'm going to spell this right. I think so. Is that an accurate? Sure. Good enough.
But there's no gingers or blonde people.
Well, I'll represent blonde people then. So let's see. Let's break this data up into multiple categories. So how many blonde people like apples? All right, Hank, you're gonna pretend to be blonde. All right, sure. Okay. How many blonde people like oranges? All right, I'll include myself in that. Bananas. There we go. There we go. Pineapples. Mm-hmm. Kiwis. Mm-hmm. Coconuts. Meh. So how about brunettes? How many brunettes like the apples?
We're all.
I'm playing a redhead.
Oh, okay. You're role playing as a redhead today.
Redhead.
1, 2, 3, 4. Okay. How about oranges? 4. Bananas. 4. Pineapples. 4. Kiwis. 4. Coconuts. 3. There we go. And let's see. Of the redheads in the room, how many like apples? 2. If I'm not mistaken, I think it's 2, 2, 2, 1. 2, 1.
Yep.
Is that right? Okay. So I've kind of gathered my data now, and I've got like a matrix of this data. And what I'm going to do is now select this.
Wait, I thought Chrissy said she didn't like oranges.
Oh, you don't? I'll change that back to 1. My apologies. I don't want to force naranjas on you. Like, yeah, we don't need to do that. Let's see. Where's this hiding here?
Donut. What's a donut graph?
Donuts are like
Bro.
kind of like a pie chart, but there was no middle.
That's why donuts are so good for you, like good for your body.
It's true. It's true.
So you're-
Let's see. Where's my 3-dimensional bar graph?
I think a bunch of 3D objects.
Here we go. So here we go. You can see,
Oh, look, you can't see the red.
yeah, 3D bar graphs, unless you can actually rotate around them, are not necessarily the most helpful. I wonder if I can change some 3D rotation here.
So you can look at it
The
from
blonde part is the most important.
Oh.
I didn't try this
look at it from the side.
Yeah, it's not necessarily that helpful. But so 3D bar graphs are clearly not the best because of their lack of visibility and interpretation for some of this. Here, that I can barely see there, but that's good enough. So here's a 3D bar graph where I'm representing lots of information. Right, Jacob, everybody, friends? But just so you see what's going on, it still represents frequencies, except I've kind of pulled this data out, and similarly to how this was broken down into 2 categories, I've now broken it down into multiple, and I can kind of view it like, you know, different ways if I wanted. It's not that helpful, I don't think, though. And also it's kind of a little bit tricky to read. So I guess you can kind of tell that that's 2 high and not 3 high. Because, yeah, the perspective, you just have to be able to perceive that perspective a little bit differently. But you can kind of get some relationships, you know, see what's going on. Actually, one of the things I could do, too, is if I wanted to break these down into percentages, so it's just not massively overrepresented by brunettes, you know, so to speak. But that's a 3-dimensional bar graph, just so you're aware of what that looks like. Good stuff, good stuff. Now, today, the thing we've been building for, nobody knows. Nobody knows. Some say the school is haunted, and that's why we're moving.
Valley Academy, I like it. Anyone else like that?
Some say that I'm retiring to become a Ghostbuster. So here we go. Frequency distribution. All right, friendly friends. Is a table. So Jacob, Kirsten, this is a table, not a graph. It's not visual in that way. That breaks data into separate classes and represents the frequency of data values in each class numerically. Interesting. Interesting. Right. So, And similarly to the kneecap question we looked at and some of these different things, this represents separate classes. So it doesn't necessarily tell me exactly what my data values are, but only how many of them fit, the frequency that the data values fit within those particular classes. So in order to do this, I'm actually going to reference a Google sheet, bless you, that I threw together here for us. So here we go. I wish I could. Well, we'll be back on that in a second. So here we go. Let's actually change this list around.
I wish you did something more controversial than fruit.
Yeah.
Okay. Oh, I'm on view only on this. Oh dear, 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 dear. Whoa, that sounded.
That is actually really racist.
No, that is not even. He said the worst about things.
So anyways, friends,
Detention?
yeah, don't be terrible people.
Oh, no.
General rule of thumb, let's be decent people in here. So I have to reconnect to this. Sorry, I was on the view only version of it. How embarrassing. Oh man, guys, this isn't cool. Yeah, you can go, Jacob. But man, my laptop, the vacuuming. Man, here's all my lesson plans so far. All right, just go away, please. Stop talking. So, frequency distribution. Here we go. Now I'm open it for reals. There we go. I'm in the right account. Okay, so let's delete these. And let's get a list of the month that we were all born in. Let's say. So for instance, me, I was born in the 4th month. So let's, how about Maddie? What month were you born in? Number from 1 to 12. There we go. Okay, Hank?
1.
Represent. Willow? 4. Ooh, nice. Connell?
4.
Ha ha! Oh boy. 10.
Wow.
Let's see. 3. And was your sister born the same month?
Yes. So
I find that hard to believe. Kirsten?
Jacob's 3 too.
Oh no, and Jacob's a 3? Oh wow, with the comeback. Wow. Guys, did you just see that happen?
I was kind of hoping 1 would kind of take away.
So what I'm going to do is I'm going to have this set up here. And there's no such thing as, maybe I'll have it count by 4s. No, 2s. Is 2s good? Nah, I guess we'll have it go by 3s. That's fine, that's fine. So what I've got is this little table here. Oh, I was zoomed in when I snapshotted it. That's fine. That's fine. It's not like this has to be professional or anything. So what I've generated is a table. And I'll write this out as well so you can see more what an actual frequency distribution is. We'll have month, and then we'll have frequency. Okay? And what I did was I broke this up into classes. So how many people were born from months 1 to 4? How many people were born from months 4 to 7? How many people were born in months 7 to 10? And how many people were born from months 10 to 13, it says, but we'll just call it 12. So, also, Jacob, we represented you with a 3 for the month you were born in. I hope that was accurate.
yes, I'm born March 24th.
And your social security number is?
I don't even know it, but I have it in my wallet.
Okay.
I put it in the back.
Could I put it up on the document camera for the internet to see?
I put it in the back with my ID, like I wrote it down and put it in the back of my ID.
Oh, great idea. Great.
And someone steals your identity too.
So, yep.
I know that I have mine memorized.
So guys, check this out. The frequency, the number of people that were born in months 1 through 4 was 5. The number of people born in months 4 through 7 was 3. The number of people born in months 7 to 10 was 1, and 10 to 12 was 1. Now, these are called the classes, all right, separate classes that I was referring to, and it's inclusive of the lower number, non-inclusive of the upper number. So it's months less than 4 is what it's saying here. So greater than or equal to 1, less than 4, all right, for our data value. So that's why all of the Marchers were in here. All of the Aprilers were included in this category, even though that says a 4 right there. So this is a frequency distribution. It's just a table, all right, so some little chart that sets things up. And it's good for us to know some language regarding these classes. So I'm going to put some little vocabulario for us to be aware of. So the class interval is the range of each class. Do you guys know what I mean when I say range? Statistically, what's the range?
Isn't that like the difference between the highest and lowest number?
Yeah. So the class interval here is 4 minus 1 or 3, and theoretically you want your class intervals to be consistent, which is why this would technically have landed on 13 there, not 12. Well, I'll just throw a 13 there for funsies. Why not? Why not? Am I right? It's just data. The class limits are the lower and upper bounds of each class. So the class limits for the first one were both 1 and 4. So you can see that I actually have the class limits here, 1 and 4. So the class was actually 1 through 4. Right, the next class was the 4 through 7. Right, 4 through 7. And then 7 to 10. So those are the limits, the boundaries of the class. And as I said, the lower limit is inclusive. The upper limit is non-inclusive. And now the class mark. That's going to come into play a little bit later. But that is the midpoint of each class. So what's the average of 4 and 1? Well, 1 plus 4 is 5 divided by 2. The class mark is 2.5. And then the next class mark is 5.5. That's halfway between 4 and 7, 8.5, 11.5. So when I talk about class marks, that's the middle value for that class. That's not saying that any of the data points land on that value. It's just what the middle value is as far as the class goes. Now, with a frequency distribution, if I wanted to represent it visually, you can do so in what's called a histogram, which is a type of bar graph. Oh, where's my histogram at? I'll snapshot it this way. Histogram. Here we go. Bam. This video is just so professional. I love it. Histogram. Oh man, you know what's sad? I can't close this. Isn't it? Oh, I did it! I'm a hero. So, a histogram is a bar graph in which the width of each bar represents a class interval, and the height of the bar represents the frequency in that interval. And wouldn't it be great if Google did this for us? Because I programmed it too. It would be great. Yeah, it would.
When did you program it?
Probably last year. No, a little bit. Actually, we'll actually program some stuff together as a class later on to see how this stuff works. So, I'll be back on that in a second. Frequency distribution becomes a histogram. Histogram. Histo. Does anyone know what the prefix histo means? History.
Information of the past.
Maybe. That sounds good. And what's a gram?
A weight.
Yeah. Or an old female person with offspring of 2 generations. So, maybe. So, check this out. I actually have a little histogram kind of generated right here. The sad thing, though, Jacob and Kirsten, is not just that you're talking right now, but that these bars are not the width. The bars aren't showing like the right width. So that's too bad. So it's technically not a proper histogram there. However,
Look one up on Google.
no, I'll show you one in Excel, though. So here's a list I've got of some data points, and I can type them in any order. I've got my limits. I said the class interval was 10, but I could actually even change it to different values if I want to. Let's say it was even 8. And then I can even say where it starts. It looks like my lowest data point is at least 0, so I think I do go at least that low. And then what it does is it finds the frequency, and just so you can see what that formula does, it counts the number of data points that are greater than or equal to the lower limit and are less than the upper limit, right? So that's how it's counting that frequency. So it's making this little frequency distribution for me, so we could pretend, I don't know, if these are like, well, hopefully these aren't people's grades because there's a lot of low numbers there. Right, so I could make a table of frequency distribution if I wanted. If I wanted a histogram, actually this is mislabeled, that should say histogram. Let's see, can I change it? Text box. Oh no, I can't change it. How about this? Histogram. Bam, there we go. You can see that the width of the bar represents the class, and the height of the bar represents the frequency. So, it represents my data somewhat visually. And technically, sadly, neither of my software things work exactly as I'd like. Technically, these values would be more like this, where they'd have the tick marks line up like so, and then I could scribble out this little 2 here, and no one knows. Look it, I just fixed it. So this class is the 0 through 8 class, of which there was a frequency of 4, and that included the 0 but not the 8. So if someone scored an 8, they would be landing in this category here. So the 8 to 16, or numbers up to 16, but greater than or equal to 8. So you can kind of see that this is a histogram. It's just a special type of bar graph. You could actually do some different things with area and that later as well if you wanted. And then the last thing we talk about today, another representation of data, is called a frequency polygon. Frequency polygon, last thing. The polygon formed by connecting the class marks of a histogram. So, what are the class marks again? Does anyone know? The midpoint. So between 0 and 8, the midpoint would be the 4. Between 8 and 16, the midpoint would be 12. 16 and 24 would be 20, right? So I could just take kind of all these midpoints if I wanted. And the frequency polygon would be what I'd get if I connected all of those. And I'm kind of doing a sloppy job. And that would be the frequency polygon, this whole thing here. Yeah, there we go. Lovely. And in fact, what do you know? I've got a frequency polygon somewhat generated here as well. But notice it's actually putting the tick marks landing at those values of the class marks. But it gives you an idea of what the frequency polygon looks like. The cool thing about these is that, let's zoom out a little bit, take it out to 150, is that I could actually change a value. So say I made, let's say I made a value at 47, that this actually automatically accounts for all of that, which is cool. So, and I could add stuff to the list. So let's say I have 51 and 52 and 52 again, and then 53.5, and like it automatically does that for me. So it's kind of nice. So anyways, so today all we were doing was just talking about different visual representations of data, kind of representing our stuff visually. We'll dig into some more core stuff with statistics a little bit tomorrow. So thanks for watching, internet friends. Maybe have a great day.